Today's lesson will be a review for the Unit 3 test. We're going to be covering questions 8 through 14. You need to have your review open from your workbook, starting on page 107. Question number 8. I need to measure 6 cups of flour for a recipe, except I only have 1/4 of a measuring cup. How many times must I fill up my measuring cup to get my 6 cups of flour? The question here is asking you to bubble in yes or no for each of the 5 different ways that you might be able to solve this problem. So you're going to have to go through 8A, B, C, D, and E and decide whether or not this is an equation that can be used to answer the question. So the first thing we need to do is figure out which mathematical equation are we going to use to solve this. Are we multiplying or are we dividing? I've created a similar problem. In this problem, I have 8 cups of flour. Here's my giant pile of flour. And instead of 1/4 of a cup, I'm going to have 1/3 of a cup in which to measure out my flour. And now I want to find out how many 1/3 of a cup will I be able to fill up from my 8 cups of flour. This means that I'm going to need to divide up my pile of flour here into 1/3 of a cups. And so I can write an equation that means the same thing. I'm going to divide my 8 cups of flour into 1/3 of a cup. Now this equation would probably be one of the possible answers that you would bubble in the yes for. If you saw an equation that said 8 divided by 1/3, you would say yes, that's one way we could solve it. We also know that we could take this equation and change it to multiplication, and we would end up with an equation that looks like this, and which would also be a valid way of solving it. We could also solve this and see that we would be able to get 24 1/3 of a cups. So the division problem equals 24. Once we know that our answer is 24, and we could then go back to our original problem and we could take a look at each of our equations and see if when solving them they would equal 24. Now I used a different problem, so we have no problems here that are going to equal 24, but you could do the same thing with this problem here. You could solve by dividing. You could see the division problem that there are 2 of them here. One of these will be the division problem you'll want to use. So one of these 2 problems will be yes. You could switch your division problem to multiplication. You have 3 choices here of multiplication problems. One of them is probably accurately written. You'll know that as soon as you write down your division problem correctly and then change it to multiplication. You could also solve each of these problems after having solved the original question up here. You could solve each and every one of these problems, and every time you get the same answer, you would know that that would be a way to do it. Now take a minute and answer question number 8 on your unit review test. Question number 9. I have a piece of cord that's 40 feet long. I love cords because I know exactly what I need to draw, a straight line. And I like straight lines because they represent number lines. So here's my cord. It's 400 feet long, so 0 would be here, 400 would be here. I want to cut this cord into pieces to tie up tomato plants in my garden. How many pieces can I get if I cut each piece 1/2 foot long? It says to draw a diagram to represent the division, and then it also wants you to write and solve an equation to find the solution. So I've just changed the problem a little bit, and I now have a 50-foot long cord, and I want to cut it into 1/4 of a foot for each piece. So I've drawn my number line and I've labeled it from 0 to 50, representing the feet. And I know that I want to cut this piece of cord into 1/4 foot long. So if I just started doing that, I would say this would be 1/4 foot, this would be another 1/4 foot, that would be 2/4, or 2/4. This would be 3/4, and this would be 4/4. 4/4 is equal to 1, so this would be my first foot. And my first foot, how many equal pieces of 1/4 foot long cord could I get by just cutting 1 foot of rope and 2/4. You can see that I have 1, 2, 3, and 4 equal pieces. So for 1 foot, I'm going to get 4 1/4 foot long pieces of rope. So for every foot that I have, I'm going to cut each of them into 1/4 foot long pieces of rope. So my next quarter would be 1, 2, 3, 4. This would be my second foot. And again, another 4 pieces. So I have 4 pieces to my first foot, 4 pieces to my second foot. And the pattern becomes more obvious as we go to the third one. I have 1, 2, 3, 4. This is my third foot. And again, I'm going to have another 4 pieces of rope. And so you can see the pattern as it starts to develop, that every foot of rope that I have, I'm going to get 4 equal pieces, and all of them will be 1/4 of a foot long. So I can take that knowledge and see that if I were to do this 50 times for each foot of rope that I have, that I would be basically adding 4 plus 4 plus 4 50 times. Well, that kind of repetitive addition is easier done by multiplying. I could simply multiply 50 times 4 and say I will end up having 200 pieces of cord, each of them 1/4 foot long. Using this same technique, take a moment please and solve question number 9. Question number 10. Of the 5th grade students, 15/20 went to the book fair. Of the students who went to the book fair, 12/16 of them bought at least one book. What fraction of 5th grade students bought at least one book? Show your work. I've recreated a new problem so that I could help you solve it. And in this problem, only 1/3 of the 5th graders went to the book fair. And of those, 2/5 of them bought a book. So we have the word of here, and we know that of means to multiply. In fact, we see it there twice. We have 1/3 of 5th graders went to the book fair. We don't know how many 5th graders there are, so we can't do a multiplication problem there to find out how many actual 5th graders went. And we're not going to be able to tell how many actual 5th graders bought a book, but we will be able to tell the fraction of those who bought a book. And the way that we're going to be able to do that is to take 1/3 of the 5th graders who went, and of them, 2/5 bought a book. So we want to know what 2/5 of 1/3 is. And then we'll know what fraction of 5th graders bought a book. So 2/5 of 1/3 is the same as 2/5 times 1/3. We don't need to invert anything because this is a multiplication problem already. So we're just going to try to cross cancel if possible. And since there's nothing to cross cancel, we can't cross cancel anything between the 5 and 1 or the 2 and 3, then we're just going to multiply straight across and end up with 2/15. And this 2/15 is the fraction of students who actually bought a book, the fraction of 5th grade students. If I knew how many 5th grade students we had, I could multiply 2/15 times that number, might be somewhere around 130, and we could tell an actual number of how many students bought a book. But for now, all we needed to do was come up with the fraction of students who bought a book. That's a simple multiplication problem. Now take a minute and complete your problem on the unit review. Question number 11. I want to plant flowers in a planter that is 1.5 feet long and 1 2/3 feet wide. I plan to cover the entire area with fertilizer. So how much area will I need to spread with fertilizer? This question is clearly asking you to find the area. And so let's do that with a similar problem. So here I have a different garden with 2 different dimensions. My length is 4 1/3 and my width is 3 2/3. In order to find area equals length times width. And so we have the length and width. So all we really need to do is to multiply these 2 numbers. They're mixed numbers though, so they're going to need to be changed into improper fractions. We'll start with 4 1/3. We're going to multiply 4 times 3 to get 12. We're going to then add our numerator to get 13, and our denominator will stay the same at 3. So we have 13 over 3. On our width, we're going to multiply 3 times 3 to get 9. We're going to add our numerator to get 11, and our denominator will stay the same at 3. So we're going to multiply 13 thirds times 11 thirds. We could try to cross cancel that, but there doesn't seem to be anything we can do there. We're going to multiply straight across. Our denominator will be 9. 13 times 11. We're going to do some double-digit multiplication. 3 times 1 is 3, and 1 times 1 is 1. Placeholder down here. 1 times 3 is 3, and 1 times 1 is 1. We're going to add those two columns and get 143 over 9, which is an improper fraction and has to be fixed. So we're going to divide 143 by 9. I've shown you this before, and this is how I would do this problem. I would do 9 into 14. 9 goes into 14 one time with 5 left over. We're going to put the 5 in front of the 3 and turn 5 and 3 into 53. 9 goes into 53 5 times, which is 45. And what's left over will be 8 out of 9. So the area is 15 and 8/9 of an inch square. If it's in inches or whatever unit of measurement you use, it will be in square units. You may rewind this if you need to see it again, and then take a moment to solve question number 11 in your unit review. Question number 12. Of the coins in my collection, 13/25 of those are quarters. Of these quarters, 2/3 are state quarters. What fraction of my coins are state quarters? Now, of the coins in my collection, 13/25, which is really close to 1/2. If that 25 was just one more, 26, we would have a half. So half of my collection almost is quarters. And of those, almost the whole amount of those, 2/3, which is 1 unit fraction away from 3/3, which would be the entire amount. So almost all of those are going to be state quarters. So I will not be able to say how many of my coins are state quarters, but I will be able to say what fraction of my collection are state quarters. You see in the question here the word of again, which means to multiply, and we see it a couple of times. Of the coins in my collection, 13/25 are quarters. I don't know how many those are because I don't know how many are in my collection. But of those, 2/3 are state quarters. So 2/3 of my 13/25 are state quarters. What fraction of my coins are state quarters? You hear the word of, we have two fractions, we should know what to do. So here's a similar type problem. In this problem, 4/5 of the coins that I have in my collection are quarters. And out of those 4/5, which is almost the whole amount, 1/3 of those are state quarters. 1/3, of course, being less than half. So I want to find out what fraction of my coin collection is state quarters. So I'm going to take my 4/5, which is 4/5 of my collection of coins is quarters. But of those, 1/3 of those, 1/3 of my 4/5 are state quarters. So here I have already set up the equation. 1/3 of 4/5. 1/3 of 4/5 is the same thing as 1/3 times 4/5. We would be looking to cross cancel anything we can, which there's nothing to do here. So we're going to multiply straight across. 1 times 4 is 4, and 5 times 3 is 15. Here is the fraction of quarters that are state quarters. And basically what this means is that out of every 15 quarters I have, 4 of them are state quarters. Take a moment now, please, and solve this question in your unit review, and then come back for the next one. Question number 13. A square do not enter sign has a height and a width of 2.5 feet. This would be easy enough to draw. Part A says, will the area of the sign be greater or less than 2.5 square feet? Explain how you know. You may not need to draw this. This kind of goes back to a prediction question that you should know that when you're multiplying two whole numbers, whether your answer should be greater than or less than your two factors. Part B says, what is the area of the sign? Show your work. So you will have to solve eventually. So here is my do not enter sign, and I'm going to create a do not enter sign that has dimensions of 3 1/4 by 3 1/4 units. We could call these units feet, I suppose. Although those would be a very big sign. And the question was, if you had to find the area of this sign, would it be greater than or equal to or less than 3 1/4 of a foot? Well, I know that I'm multiplying two whole numbers here, even though I have to change my mixed numbers to improper fractions, and each of this would become 13/4, which is the same thing as 3 1/4. Even though I know I need to do that to multiply them, I don't need to multiply them to know that my answer is going to be larger than 3 1/4 feet, because I'm multiplying two whole numbers. And anytime you multiply two whole numbers, or two numbers bigger than one, even if they have fractions with them, your answer is going to be larger than either of the two numbers you started with. So that prediction part is fairly simple. It's going to be larger. And now I need to actually find the answer. So I'm going to have to multiply 13/4 times 13/4. And I'm getting, remember, 13/4 because these mixed numbers need to be changed to improper. And then I'll try to multiply straight across. And then the bottom number is 16, but 13 times 13 is going to take a little extra work. We're going to do 3 times 3, which is 9. 3 times 1, which is 3. Placeholder. 1 times 3, which is 3. 1 times 1, which is 1. Add them. You get 169/16. Well, then we need to divide to find the actual answer because this is improper. 16 goes into 16 one time with 0 left over, so I'll put the 0 in front of the 9. And 16 goes into 9, 0, 9 equals 9. 16 goes into 9 0 times, and there are going to be 9 left over out of 16. So my final answer with my new problem is 10 9/16. Now I would like you to take a moment and solve your question, number 13, and then come back for the final question. With question number 14, our final question on the test, we are going to skip the rest of the questions on this test. We're only going to go 1 through 14. On this question, I'm going to just solve the original problem with you. You can go ahead and follow along with me. I want to make sure that you understand where these numbers are coming from. All right, I have a model that I'm using to help me solve a multiplication problem. Part A says use the numbers from the list. We're going to be using numbers over here. We have 4 choices to fill in our 2 blank spots. There will be points given if you put the right numbers in, and as well as a point given if you solve the answer correctly. Notice that we have 2 squares here. These are basically 2 squares. You can tell that they are 2 whole squares because of the dark line cutting them, dividing them into 2 in the middle here. So we have 2 whole squares. They're really 2 holes. We can tell that each square by itself is cut into 1, 2, 3 equal places horizontally, and vertically cut into 1, 2, 3, 4 equal places. We could find the area of one square if we wanted to by simply just counting our squares. There's 3 and 4 here. If we look at this as an array and multiply 4 times 3, we could see that the area would be about 12. The total area for both of them then would be 24. There's 24 equal squares within both of those squares. But I've only highlighted a certain amount of them. You can tell with our brackets here from this right here all the way to the end, I've highlighted. And from the top here, only down 3 blocks have been shaded as well. So we're only dealing with this section right here that is double shaded. That's the area that we're looking for. So while I start looking for the fraction over here that would go in this box, I'm looking for a fraction that represents from this first box over here in our second whole box all the way past the first whole box and to the second equal square here. So really what I have here is I'm shading one entire box horizontally plus 2 out of 3 more of the final box. So one whole box, these three here, which is one whole, plus two more. Which fraction over here is equal to one whole plus two more, or two extra? So when we take a look at our fractions, what we notice right off the bat is this fraction here and this fraction here are improper. The first fraction is improper, and if we fixed it, 4/3 would equal 1 1/3. 1 1/3 is not what's being represented here. One whole is being represented, but this is not a third. This is really 2 out of 3, or 2/3. We look at 5/3. 5/3 is really 1 with 2 left over out of 3. So there's the fraction we're going to want to use here, 5/3. This is being represented by 5/3 because 5/3 is really equal to 1 whole and 2 out of 3. Well, this is 1 whole, 3 out of 3 is a whole, and 2 out of 3 is being represented over here. So now we need to look at the width, which is from here all the way down. And this is a lot simpler one because we have 1, 2, 3, 4 equal places and 3 are being shaded. So we're looking for the fraction that represents that. That's 3 out of 4, or 3/4. That fraction is here. So we're using both of these fractions. That concludes part A. That will get you the point on part A. To get the point on part B, you're going to need to follow through and find the area, which means you need to write your fractions down and solve. We can immediately see that we can cross cancel our 3's. They will both become 1's. We'll divide them both by 3. And now we can multiply straight across and get 5/4, which is improper and needs to be fixed. 4 goes into 5 one time with 1 left over out of 4. Our final answer is 1 1/4. You could probably see that if you were to take a couple of your boxes here and fill them in down here. We would need to take 3 of our double shaded boxes here that are part of our area and fill them in over here. So I'm going to do that really quick so you can see. I'm just going to pretend that these are now double shaded. And I'm going to also kind of eliminate the 3 that I replaced. I actually took these 3 out and put them down here so that I could see that now I have one full entire rectangular or square, one full square is double shaded. So this would represent the 1 in our area of 1 1/4. And now I can take a look at what's left over here, and I see that I have 1, 2, 3 shaded left, double shade still. 3 are left out of a total of, how many does it take to fill up this whole square? There's 3, 6, 9, 12, so out of a total of 12. So 3 are left out of 12. So I have one entire box shaded area-wise, that's the 1, and 3 left out of 12 if I were able to take these 3 out and put them here. And 3/12 is really equal to 1/4, so we can now see that 1 1/4 is correct. Here's my 1, and here's my 1/4 right here. So you could see it visually if you're able to pull the boxes out and put them in a different spot. Congratulations on completing your test review. And remember, tomorrow is your final test, questions 8 through 14. And please go home and study tonight so you could do really well, and good luck to you tomorrow.